Hello, my name is David Berry. Welcome to this module on connections and connection pooling. I want to take a few minutes to discuss how an application connects to an Oracle database. Connecting to Oracle is one of the most fundamental tasks, and is one of those tasks that we rarely give a second thought to. However, there are some practices that you should follow in order to make sure that your application doesn't encounter unnecessary waits as a result of not managing connections correctly. An important aspect of achieving the highest performance possible is to use connection pooling. When your application uses a connection pool, you keep a number of physical connections to the database open at all times. And then when your application code needs a connection to the database, it will borrow one of these connections that is already open from the connection pool. After this block of code is finished executing the data access calls it needs to, it will return the connection to the pool so that it can be used by a different block of data access code. The advantage here is that you're able to reuse physical connections to the database server, and this is much faster than establishing a physical connection to the Oracle database server every time you need to execute some data access code. Establishing a TCP connection across the network, allocating the PGA memory on the Oracle server, and other associated overhead all takes time, so being able to check out a connection that already exists is much faster. What happens if a piece of data access code in your application tries to check out a connection from the connection pool, but all of the connections are currently in use? The connection pool will recognize this situation, and it will go ahead and open up a new physical connection to the database, add this connection to the pool, and return it to the requesting block of data access code. Conversely, if there are a number of connections in the pool that haven't been used in a period of time, the connection pool will go ahead and close these connections in order to conserve resources on the database server. In this way, the size of the connection pool will vary up and down depending on the amount of data access activity occurring in your application. It is important to know that there will be a connection pool established for each unique connection string that you are using in your application. So if your application connects to 2 or more Oracle databases, or perhaps connects to 2 different schemas on the same Oracle instance, in both these cases, each connection string will have its own connection pool. Each connection pool will have a minimum and maximum size, and these are just like they sound, the minimum and maximum number of physical connections the pool will maintain to the Oracle database. If your application has a period of time where the usage of the app is very low and not very many connections are needed, then the connection pool will contain code that will close unused connections, and you would see the number of connections in the pool go down over time. If your application is idle for a long period of time, say in the middle of the night when everyone has gone home, then you very likely would see the connection pool would only contain the number of connections specified in the minimum pool size. As we just discussed, if your application requests a connection from the connection pool, but all existing connections are currently in use, the connection pool will automatically establish a new physical connection to the Oracle database and return this connection to you. And so in this way, the number of connections in the pool is dynamic. During busy periods, the number of connections in the pool will increase to help match the load. During slow periods, idle connections are automatically closed. What is even better is that all of this is managed for you, and there's nothing that you have to do in your application in order to take advantage of this. There is one other scenario, though, that you should be aware of, and that is when the connection pool is already at its maximum size, and all of the connections in the pool are in use. What happens then when another piece of data access code requests a connection from the pool? The answer is that the thread running this piece of data access code will have to wait until a connection becomes available. So in the example we see on the screen, once one of the other threads finishes with its connection and returns it to the pool, this connection will now be assigned to our waiting thread. If no connection becomes available within a specified period of time called the connection pool timeout, then the connection pool will throw an exception on the thread waiting for the connection, and you will need to handle this exception in your application code. There are some important implications here for how you use connections and how long you hold on to connections in your application code once you've checked a connection out from the pool. But the general rule is that you only want to keep a connection checked out from the pool as long as you need to and no longer. Otherwise, you could cause other threads in your application to block while they are waiting for connections. Let's take a look at a couple examples of connection pooling in action to understand why this offers a performance benefit.